In math, matrices are a convenient way of listing out a sequence of numbers that are related to each other. They also make it very easy for you to perform operations that affect all of them at once. Well, it's April Fool's Week, so let us start slow. Let us have our Monday episode be a math-related episode, and we'll ramp it up as we go along. In today's episode, we'll be looking at some basics of matrices, as well as some operations you can carry out on them. You're watching another random Monday video on 0612 TV. Hello and welcome back to a special Monday video on April Fool's Week, the week in which this tech channel gets to take a break and talk about any other topic under the sun. As promised, we'll be looking at matrices today. We're going to be trying to understand what a matrix is, as well as some very simple operations that can be carried out on one. So let's start with the most fundamental question, and that is, what is a matrix? A matrix is simply a sequence of numbers held in a grid pattern. We can actually describe the size of a matrix by referring to its number of rows and its number of columns. For example, this particular matrix is a 2x4 matrix. We call it that because there are 2 rows and 4 columns. So yeah, it is a 2x4 matrix. Just like simple numbers in math, matrices allow you to perform operations like addition or multiplication on them. You'll find that some of these are simple, they're very straightforward, and others require a little bit more thought. So yeah, let's take a look at some of the basic operations that can be performed on matrices. First up is addition and subtraction. Now, these are very straightforward. In fact, what you intuitively believe is correct is correct. All you have to do is to simply add or subtract from the corresponding items in each row and column. So what this means is this addition here simply involves taking all the corresponding items and adding them up. That makes up the result. So we'll have to repeat for as many entries as there are in each matrix. Same deal for subtraction, look for the corresponding elements, do a subtraction, and repeat for every other element there is. What this means is for addition and subtraction, you're going to have to use matrices of the exact same size. If either matrix has either too many or too few rows or columns, this entire operation fails. You cannot perform the addition or subtraction at all. I don't know how obvious this is, but I guess it's worth mentioning that the same idea holds true for equality as well. If I say that 2 matrices are equal, what I mean is that at all corresponding locations between the 2 matrices, the entries have the same value. So yeah, that's addition and subtraction, very straightforward. Let's move on to multiplication, and that's where the fun begins. Now, when it comes to matrix multiplication, you cannot simply take all the elements and just multiply them pairwise. Instead, what you need to do is a pretty complex kind of step. Here's how this works. Let's say I want to perform a multiplication of these 2 matrices. To identify the result of the first entry in the result matrix, we're going to have to refer to the entire first row of the first matrix and the first column of the second matrix. Then what we're going to have to do is we're going to have to move down these 2 highlighted lines and basically multiply each corresponding term with each other. When we're done performing all these individual multiplications, we're going to have to sum them all up, and that gives us the results at that position in the result matrix. To calculate the rest of the result matrix, well, we're just going to have to refer to the other rows and the other columns. So for example, the second entry will rely on the second column of the second matrix. Basically, the rule of thumb is when you're looking at row I and column J of the resulting matrix, you're going to have to look at row I of the first matrix, you're going to have to look at column J of the second matrix, then simply move down this row and this column and multiply the corresponding values together, sum it all up, and that gives you the result at one entry in the resulting matrix. In fact, this entry will be located at row I, column J. So yeah, it's a little bit complex, but I think if you try and follow this process a few more times, you'll get used to it. It's just a little bit tedious. Of course, knowing how matrix multiplication works should also tell you that you cannot multiply any matrix to any matrix. In fact, when it comes to matrix multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. As for the size of the result, well, the number of rows it has will be the number of rows in the first matrix. The number of columns it has will come from the number of columns in the second matrix. It sounds very abstract when we argue it like this, but you'll be able to see why this is so by actually tracing out a matrix multiplication. Obviously, the restriction on size is required because if we don't have it, then there'll be an element that multiplies with nothing, and we can't have that. The size of the result comes naturally from following the multiplication. Oh, and here's another thing to note: when we're dealing with numbers, multiplication is commutative. What that means is A times B and B times A will always give you the same result if you're using numbers. However, that is not the case when it comes to matrix multiplication. Matrix multiplication is non-commutative, and here's a simple counterexample to prove just that. So yeah, that was multiplication. Now, apart from these fundamental operations, there are also several operations that makes more sense on a matrix, the first of which being a transpose. Now, transposition basically works like this. You want to look for the diagonal of the matrix, that is, well, the rows in which I and j are the same, I being the row number and j being the column number. This gives you a diagonal line going from top left to bottom right, and that identifies the diagonal of the matrix. A transposition is when you flip the entire matrix about that diagonal line. So the elements on the diagonal stay the same, but all the other elements actually go around. That is a transposition, and if you transpose a transpose, you get back the original result. The transposition operation is indicated as a superscript T. Another operation is an inverse. Now, before we look at inverses in terms of a matrix, let's look at it in terms of just numbers. If I have a number, say 3, and I multiply it by its inverse, in other words 1 over 3, I'll get the result 1. The same idea applies to a matrix. If you can find the inverse of a matrix, you multiply them together, you'll get what is known as the identity matrix, which is the equivalent of 1 in matrix terms. Why is it the equivalent of 1? Well, as it turns out, when you actually multiply a matrix by the identity matrix of the correct size, you'll get back the exact same matrix. So yeah, it works just like multiplying by 1, as in the value doesn't change. While finding the inverse of a number is easy, it is much harder to do it on a matrix, and in fact it is so hard that we're not going to talk about it today. You can look it up for yourself if you want. It does involve some pretty complex concepts. So yeah, let's skip it over since we're just doing a bit of a crash course. In fact, I think we should wrap it up here. Like I said, this is meant to be just a very quick crash course. I don't want to go into all the nitty-gritty details because when you go into them, they are pretty intimidating. So yeah, that's basically it. These are all the fundamentals you need to know when it comes to matrices, and depending on the application, this knowledge can already be quite sufficient. Of course, having said that, many other concepts and operations do exist around matrices, and especially when applied to solve particular problems, matrices can be extremely powerful. Hopefully today's video has been enough to give you a rough context about matrices so that, when you see them in literature, whether you're studying things like computer graphics, well, it can be of some help to you. Anyway, that's all there is for this episode. Thank you very much for watching, and until next time, you're watching 0612 TV. Thank you very much for watching. If you liked this video, consider checking out the rest of my work on my channel. Alternatively, you may be interested in my other vlogs. If you'd like to show me some monetary support, I am on Patreon. You can find a link to my campaign in the video description. Of course, you can simply like this video or leave a comment. I'll be sure to respond as soon as I can. To keep in touch with my future uploads, do subscribe to this channel, And for even more updates, check out the official Twitter account for this channel at 0612TV. Thank you for your support.